All right, so we're going to talk today, over the next couple of weeks, about exponents. We're going to start off talking about how to deal with zero and negative exponents, something that I believe you've seen before. Okay, so the point, what we should be able to do by the end of this session is to simplify expressions involving zero and negative exponents. Okay? So, quick review here. If you want to evaluate these three, okay, we have, remember, this is called your exponent, this is called your base. Exponent tells us how many times to multiply the base together. So 3 squared means we're going to do 3 times 3, or 9. Same thing here. Exponent's 5, base is negative 3. That means negative 3 times negative 3 times negative 3 times negative 3 times negative 3. So, basically, this negative times a negative makes a positive, so we're going to get positive 9 times positive 9 times negative 3. 9 times 9 is 81. 81 times negative 3 is negative 243. Okay? This is negative, whereas if I multiply negative 2 together 4 times, okay, this becomes positive 4, this is positive 4, 4 times 4 is 16, so this becomes negative. So just a quick reminder that a negative base, if it has an odd exponent, the result will be negative. A negative base with an even exponent, the result will be positive, and that's why. Okay? All right. Now, what happens if our exponents are negative? Okay? If you were to type 4 to the negative second power in your calculator, if you know how to do that, you should. And the result would kind of give you an insight as to what we are going to want to do here. Okay? But as it turns out, and there's a good reason why, so if you need that reason explained to you, make sure you come see me during STAR or after school, and I'll walk you through why. It's pretty neat and pretty easy to understand. But basically, if you type 4 to the negative second power into your calculator and you let your calculator give you your result as a fraction, you would find out it's 1 over 16. Well, if you rewrite 16 as a base of 4 and an exponent, you'd get 1 over 4 squared. Look what happened, right? So when we have a negative exponent, we want to drop that base into the denominator and make the exponent positive. Same thing would happen here. Now, since the y is the only base that has a negative exponent, it's the only one that's going to move. Okay? The x to the third would still stay in the numerator, and so you'd have x to the third over y squared for this last guy. If you're asking yourself where the denominator is, remember we can always make anything a fraction by putting it over 1. Okay? But bottom line is, when you have negative exponents, you're going to want to change bunks, right? If you can view a fraction as sort of bunk beds. Anytime you have a negative exponent, what ends up happening is if you were to move it from the denominator to the numerator, or from the numerator to the denominator, the exponent will become positive. It's almost like the fraction bar becomes the great sign changer for exponents. Okay? So, how does that work? Well, we've already seen this a little bit. So, c to the negative fifth, if we wanted to make this exponent positive, and we always do, we want positive exponents, we would simply drop c to the negative fifth into the denominator of a fraction, make the exponent positive. But if we are dropping everything from the top bunk to the bottom bunk, there has to be something in this numerator. There has to be something left in the denominator, and it makes sense that this something is a 1. So you get 1 over c to the 5th. Okay? Here, remember the fraction bar I said before is the great sign changer. No matter where the base is, if you move that base across the fraction bar, it will change the sign of the exponent. And since right now both of these exponents are negative, I want to change both of those signs. So I'm going to move both bases across the fraction bar. So here's my fraction bar, which means I'm going to take the q and move it up and the z and move it down. So we would have q to the 3rd over z to the 5th. Move the base and flip the sign of the exponent. That's what we're getting at here. Okay? Does this make sense? Try number 3 real quick. I'll give you a couple seconds and see if you're right. Okay? Again, the fraction bar being the great sign changer for exponents. We're going to drop the x down and the y, move it up. Y to the 3rd, x squared. When you move the base, you change the sign of the exponent. Always. That will always happen. It would happen for positive exponents also. If you had 1 over x squared, and I moved this up, then it would become x to the negative 2nd power. But we're not ever going to want to do that. We want our exponents to be positive. Always want them to be positive. What about a situation like this? We have 2/5 to the negative 1st power. I'm going to show you why this happens the first time, and then just bottom line it and talk about how you want to do this each time after this. Again, any base with a negative exponent, we need to drop down into the denominator of a fraction. So even if your base is 2/5, drop that down, we leave a 1 behind. But remember that when you divide by a fraction, it's the same thing as taking and multiplying by its reciprocal. 1 times 5/2 is simply 5/2. And so if you look, what happens when we raise a fraction to the -1 exponent, or any negative exponent, we just simply flip that fraction over and make the exponent positive. Okay? So flip the fraction, make the exponent positive. And in this instance, where the exponent would be a positive 1, we don't write it. We know it's there, but we just don't write it. Okay? All right. Number 5. What would happen with number 5? Be careful. Now that we've introduced what to do with these negative exponents, you're going to want to take care of all negative signs. And it doesn't quite work that way. Since this base of -5 has a negative exponent, we're going to drop it down into the bottom of a fraction and change the exponent to a positive, leaving a 1 behind. But notice that we did not change the negative sign on the base. We do not change the sign on bases. We only change the sign on exponents. It's okay to have a negative base. It's not okay to have a negative exponent. So when you multiply all this out, -5 times -5 times -5, you get negative 125, and so that's what we get when we simplify. Okay? Here we return back to normal a little bit. 5 is our base, -2 is our negative exponent. We're going to drop it down into the bottom of a fraction, leaving a 1 in the numerator, and we get 1 over 25. Okay? Excellent. Whenever you have a 0 exponent, and again, there's a really cool reason as to why this is always going to be true. And I would love to show that to you. Come in and see me, and I'll make sure that I do. But the bottom line is, whenever you have a 0 exponent, set it equal to 1. Anything to the 0 power is going to be 1. It doesn't matter what number we're talking about. If I raise this power to the 0 power, it's going to be 1. Always, always, always going to be 1. Okay? So, x to the 0, guess what? It's 1. Center Grove Trojans to the 0, guess what? It's 1. Truck to the 0, guess what? It's 1. Okay? Even something as ridiculous as 27x to the 3rd, y to the 17th, z to the 72nd power, if we raise all of that to 0, it's just going to be 1. Okay? It will be automatic. So, 1 over z to the negative 3rd power raised to the 0 power. Guess what? It's just 1. That's it. Okay? Now, what about simplifying something like this? Use what we know so far. B to the 0 is 1. We know that. Okay? Now, start thinking about this. Any negative exponents, we've got to move the base for. Look at the 6. Is the exponent on the 6 a negative? Hopefully you're saying no, it's not. And hopefully you understand that even though we don't write the exponent in here, it really does exist. It's a 1. We know that 6 to the 1st power is just 6. So an exponent of 1 doesn't change anything, so there's no reason to write it. But it's still there. It's just like coefficients of 1, right? We don't write it, but we know it's there. So does the 6 need to drop down into the bottom bunk or the denominator of the fraction? The answer to that's no. Its exponent's positive, so it's going to stay here. Now, the a has a negative exponent, so it needs to drop down. And the c has a negative exponent, so it has to drop down. And so when it does, the exponent of 1 becomes positive, which we don't necessarily need to write. And the exponent of negative 3 becomes positive and becomes c to the 3rd. And now we're done. Yeah, we had this 1 in the denominator, but remember that we're multiplying all this stuff together. So if you had 1 times a times c cubed, it would simply stay ac cubed. Okay? All right. You start simplifying these. Take a couple of minutes, try to come up with something, and start the video back up and check your answer. Okay, what'd you get? Go through these one piece at a time. Going to have a fraction bar. Do we need to move the 2? The exponent's of 1, so no, we don't need to move the 2. Do we need to move the z? The exponent's negative 7, so yes, we need to move the z. So we get z to the 7th down here. Do we need to move the negative 7 up? Now, yes, the 7's negative, but bases can be negative. It's exponents that cannot. So its exponent is a positive 1, so we don't need to move it, so it stays here. X has a negative exponent, so we got to move it up to make it positive. And then y to the 4th has a positive exponent, so it stays where it is. And so that is the result that you get. Okay? What about this? What would you come up with here? Try it, and then check your answer. Okay? That's going to be 1. Okay, so 1 times x to the negative 5th is just x to the negative 5th. So how would you fix x to the negative fifth? We've got to drop it down into the denominator of a fraction, leaving a 1 behind, and it's simply that. What about this guy? Take a second, come up with something, start the video, and check your answer. Okay, so first off, our fraction has a negative exponent, so flip everything over first, and then worry about moving negative exponents. Now, the only thing that has a negative exponent on it is the y, and so the y is going to have to move into the bottom, to the denominator of the fraction, and change the exponent to positive. That's it. Don't move the 2. The 2 is perfectly fine where it is. It has a negative base, but the exponent's not negative. That's all we're really concerned about. Okay. What about here? Well, hopefully you're saying to yourself, this whole base has a negative exponent. So we got to push this whole base up to the numerator. And so we get 1 times negative 3x, or just negative 3x. Okay. Now, what if we need to evaluate, right? What if we have some numerical values for our variables? What's the best process to go through and evaluate this? And my suggestion to you is to fix all the negative exponents first, and then worry about plugging in the values for your variables. For example, number 13. We have a negative exponent on this base. So drop that base down into the denominator. And you get m to the third, m cubed, over n squared. Now plug in your numbers. Since m is negative 2, we get negative 2 cubed over 3 squared. Okay, well, negative 2 cubed, negative 2 times negative 2 times negative 2 is negative 8. 3 squared is 9, so we get negative 8 over 9. Okay? Try 14 and see what you come up with. Stop the video and then you can check your answer. Okay, what'd you do? Fix your negative exponents first. This one's got to drop down, this one's got to drop down to where you get 10 over mn cubed. Okay, now plug in your values. 10 over m is negative 2. Remember that when we write mn cubed, what that means is that's m times n cubed. So we get negative 2 times 3 to the third power. That gets us 10 over negative 2 times 3 to the third power is 27. So we get 10 over negative 54, which is negative 5 over 27. Okay? And that's it. Got one more here with m and n. So, what are we going to do? Well, we got a negative exponent here. He's got to move up. N to the 0. I don't care what the value of n is. N to the 0 is just 1. So we're left with m squared in the numerator and 5 in the denominator. So we get negative 2 squared over 5. Negative 2 squared is 4, positive 4, so we get 4/5. Okay? Now, it says you try, and we're missing some values. We're going to use the value of m and n from up above. But you might want to write this down. We're going to let p be 6, x be 4, and y be negative 3. Okay? So, if that's the case, you try this. Fix your negative exponents first, then plug in your values and do your arithmetic. So what'd you come up with? Drop this guy down first, right? So you get negative 3 x to the fourth over 4y squared. Negative 3 times, and x we said was 4. So we get 4 to the fourth power, that's going to be big, over 4 times, and y was negative 3, so we're going to do negative 3 squared. Okay, so what do we get? 4 to the fourth power. 4 times 4 times 4 times 4, I think, is 256. I'm going to type this into my calculator, and indeed it is. So we get negative 3 times 256 all over negative 3 squared is 9. 9 times 4 is 36. I'm going to work a little smarter and not harder and simplify this. So this is going to be a 1, and this is going to be a 12. So I get negative 256 over 12. And then we're going to simplify all of that. I can divide these by 2. This becomes 6. And this becomes 128, or negative 128. Divide it by 2 again. And we get 3 here, and we get negative 64 here. So we end up with negative 64 over 3, and that's as far as we can go. So a little tough simplifying, but there you go. Okay? Same thing for 17. Give it a shot. You've got the values of m, n, and p, and see what you come up with. Okay? Fix your negative exponents first. This whole thing's got to move up. This end's got to move down. So we get m. As a matter of fact, we get 2p. Actually, 2p to the first power, or just 2p. So 2p times m over n to the fourth. And so now we go 2 times 6 times negative 2, I believe. I'm going to go back and check. Yes. Negative 2. Over, well, shoot, n is 3, so 3 to the fourth. 2 times 6 is 12, times negative 2 is negative 24. 3 to the fourth is 27 is 81. Now, both these can be divided by 3 for sure. This is going to be negative 8. And this is going to be 27, and I think it's as far as we can go. So we get negative 8 over 27. Okay? Good? All right, one more. Try this. Okay, what happened? Got to drop this guy down. So we get 5y over x squared. So you get 5 times, and y we said was, I've already forgotten. Y is negative 3, x is 4. So we type in negative 3 down here. This is 4 squared here. So we get negative 15 over 16, and that's it. Okay? Hopefully it makes enough sense. You got homework in Canvas. Make sure you work on that and have that ready by next time.